Okay, so we've got to do let's get our third video as follows. Um, we were doing problem number 8, but we just ran out of time, basically. So let's go to problem number 8. This is exam 1, review C. It's our third video. We're only on problem number 8. So problem number 8 says -3 over 11 plus 2 square root of 7. What does it say on top? It says rationalize the denominator. Those are the instructions. Rationalize the denominator. What do? Multiply the denominator by its conjugate, which is 11 minus 2 square root of 7. And whatever you do to the bottom, you got to do to the top. 11, multiply that by 11 minus 2 square root of 7 equals, let's do the top first. -3 times 11 is -33. -3 times -3 times -2 square root of 7 is going to, -3 times -2 is going to be +6. And the square root of 7 is not going anywhere. We've got the square root of 7 up there. Okay, now the bottom is going to take a lot longer. 11 times 11 is going to be 121. When you multiply by conjugate, you know that this is going to be minus 22 square root of 7. This is going to be positive 22 square root of 7. I know they're going to cancel each other out, so I'm not going to bother with outside times outside and inside times inside. They cancel each other out. You can look at previous videos with conjugates. That's what happened every time. So I'm just going to do the first times the first and the last times the last when I'm dealing with conjugates in this case to save a little time. 2 square root of 7 times 2 square root of 7 is -4 times 7. What's the square root of 7 times square root of 7? It's 7 itself. So 2 times -2 is -4. And square root of 7 times square root of 7 is 7. Square root of 513 times square root of 513 is 513. Square root of 7 times square root of 7 is 7. So this turns out to be -4 times 7. All right, give me a little more time here. -33 plus 6 square root of 7. What's on the bottom here? 121 minus 28. Let's keep going. I'm going to do it over here. -33 plus the square root plus 6 square root of 7 over 121 minus 28. That's going to be 93. We're going to have 93 left over, right? 121 minus 21, whatever. 20. If you take 20 away from the 28, so you'll get to 100. And you'll have 7 left, so you go down another 7, you get 93. So 93 is the denominator. Now, is this divisible by 3? Yes. Is this divisible by 3? Yes. Is this divisible by 3? Yes. I know this is divisible by 3 because 9 and 3 is 12, and 12 is divisible by 3. Okay, so let's divide by 3. Let's keep going this way. Divide by 3, I get -11. Divide by 3, I get 2 square root of 7. And divide this by 3, and I get 31. 3 times 3, 3 times 3. 3 times 1 is 3, 3 times 3 is 9. I get 31. Is there any number that will go into all 3 of these? No. Therefore, this is my final answer. The denominator is rationalized. There is no radical in the denominator. Okay, that is problem number 8. Problem number 9. What do we have? We've got 8 square root of 45 plus the square root of 80. Okay, we've got to, wherever we can simplify the radical, we must simplify the radical. Obviously, we don't have like terms here, but maybe when we simplify everything, we'll get like terms. Let's see. Well, the square root of 45 can be broken up into the square root of 9 and the square root of 5. 9 is a perfect square. That in turn will turn into 3 square root of 5. And don't forget, this 8 is still hanging around. It's going to be multiplying the 3. All right, but hold on. What about the 80? What can I split that up into? I can split that up into two things. What's the biggest square, perfect square underneath 80 that is a factor of 80? 16. 16 times 5 is 80. 50 and 30, 80. What's the square root of 16? 4. And the square root of 5 is a leftover. It comes down. There is no number here to bring down. There was the 8 that had to come down, but there's no number here. So this plus is still going on here. This plus is still going on here. What do I have? I have 24 square root of 5 plus 4 square root of 5, which is equal to 28 square root of 5. And the problem is over 28 square root of 5. We finally have the final answer for problem number 9. Okay, might as well go to a clean sheet of paper to start off problem number 10. Okay, get rid of this piece of paper. Go fetch another paper. And there we go. Okay, now let's go to problem number 10. Problem number 10. What is it? It is negative 6a to the negative 8 power, b5, b to the 5th power, all of that taken to the 3rd power, and the answer has to have, it's got to be positive exponents, no negative exponents. Similar to problem number 2 on the first video that we did for this exam. No, it's got to be positive exponents. Okay, take the 3rd power, take this 6 to the 3rd power. What is negative 6? This is my scrap paper. What is negative 6 times negative 6 times negative 6? It's a little bit of on the big side, this number. Negative 6 times negative 6 is 36. And 36 times negative 6, let's just do 36 times 6 first. This is going to be 6 times 6 is 36, carry the 3. 6 times 3 is 18 and 3. So that's going to be 18 and 3 is 216, but it's going to be 36 times negative 6, right? So therefore the answer is going to be negative 216. Right? Positive times negative is negative. So the number that we have over here is negative 216. A to negative to the 3rd power, power to a power, you multiply, so that this is a to the negative 24. And b5 to the 3 is going to be b15. But we've got to do one more thing. We can't leave that negative 24 there. So negative 216 is going to stay where it is. b15 is going to stay where it is. But the a to the negative 24 is going to dump the a and 24 in the bottom without the negative sign, without the negative next to the exponent. And this is the final answer for problem number 10. Okay, let's go to problem number 11, which we do have room for, I believe, even though it might take a couple of steps. Problem number 11 looks like this. Okay, let's cordon this off. There we go. Problem number 11. What if you have a over a squared plus 2a minus 3 plus, add to that, so this is a minus, that's a minus, plus you've got the number 3 on top in the numerator, and you've got another a squared plus 2a minus 3, so that's good news. The good news is that we have a common denominator here. So that means that will be equal to, that's the question. We're getting towards the answer. Here's we're going there. First step is that this is equal to a squared plus 2a minus 3. Then you got a common denominator, so just put a plus 3 on top, above that. Now, on scrap paper, let's go factor a squared plus 2a minus 3. Let's factor that. So let's see if it works with the magic numbers. We've got the coefficient of a squared is 1, so maybe we can work with the magic numbers. What are two numbers? When you multiply them together, you get negative 3. And when you add them together, you get positive 2. So there's a number for that. There's two numbers for that. 3 times -1 is -3. And 3 plus -1 is equal to +2. So our magic numbers are 3 and -1. So a plus 3 is the numerator, not changing. The denominator changes into, after we factor it, a plus 3 and a -1. That's what we needed to factor on top. And now we can see that we have something that we can cancel, which means the final answer is 1. When nothing's left on top, that means there's a 1 on top, a minus 1, and that is the final answer for problem 11. Okay, so again we ran out of paper. Let's go get another piece of paper and see if we have time for another one on the same video. So let's get rid of this page. Gone. Here comes another clean piece of paper. And let's see if we can't do a little bit more on this video. Next, we need to solve, this is going to be problem number 12. Problem number 12. We need to solve 3w squared minus 12w equals 0. That means we've got to solve for w, obviously. Okay, so there's two things over here. What we need to do is factor and get the coefficient, get the GCF, not the coefficient, the greatest common factor out of there. GCF, that's what we need to do, and take this out. Okay, so 3 and 12, those are the numbers. What comes out of the parentheses as far as numbers is concerned? 3 and 12. Well, 3 goes into 3 and 3 goes into 12. Bring that out. Leave a space for the w's. W to the second power and w to the first power. Take the smallest of the two. Bring out the w. What is 3w squared divided by 3w? The 3's cancel. W squared divided by w is w. And what's negative 12w divided by 3w? Well, the w and w cancel. Negative 12 divided by 3 is going to be, divided by positive 3, is going to be negative 4. Negative divided by positive is negative. Equals 0. And now we set up the t. 3w is equal to 0. Just like we set up the t with two binomials, we set up the t in this case too. 3w gets its own 0, and w minus 4, I don't need the parentheses anymore, gets its own 0. W divide by 3 on both sides, and you know that w is equal to 0. Here's one answer. Plus 4 on left, plus 4 on right, and w is equal to 4. Here's the second answer, and problem 12 is done. Okay, here comes problem number 13. We had this, almost the same exact stuff on the first review, and it was on the first test, I believe. 6.4 for exam 0. 6.4 times 10 to the negative 11 on top, and 0.8 times 10 to the 4. And we're supposed to take care of this. Okay, my scrap paper. Let me put it down here, scrap paper. What is 6.4 divided by 0.8? Well, that's the same thing as 64. Move the decimal place over 1. 64 divided by 8. And what do I get? I get 68 doesn't go into 6, it goes into 64 8 times. So over here, as part of the answer, it's going to be 8 times 10 to the something. Negative 11, and this is on the bottom, so it's a minus, so I subtracted from it there. So it's a negative 11 minus 4. That's negative 11 and negative 4 is negative 15. And here is the bottom line answer for problem number 13. Here we go. Let's shut this down. And this video is done. We'll have to go on to another one.